Hello students, my name is Om Prakash Dubey and I am faculty of chemistry. In this session I am going to discuss about the acid-base titration. The titration, which is an experiment which is carried out to determine the strength of unknown acid solution or unknown base solution, and the indicators used during this experiment. Now, let us acid-base titration. Different types of acid-base titration are there, like strong acid, strong base titration, strong acid, weak base titration, weak acid, strong base titration, and weak acid, weak base titration. 4 different types of titrations are there. The indicators used during the titration to know the equivalence point or the end point of titration. End point of titration is actually theoretical equivalence point of the titration. Equivalence point of titration is the point at which the acid completely neutralizes with the base or base completely neutralizes with the acid. There are different types of indicators which are used during the acid-base titration, and their color change and the pH range in which they shows the color change. Like first is the methyl orange. The color of methyl orange in acidic solution is red, and in basic solution it becomes orange, and the pH range is 3.1 to 4.4. That means in this range the methyl orange shows the color change during the experiment. Second type of indicator is methyl red, which acid color is red and its base color is yellow, and the color change is 4.4 to 6. pH range is 4.4 to 6. The another indicator is bromothymol blue, which acid color is yellow and the base color is blue, and the pH range of this indicator is 6 to 7.6. Phenolphthalein, another type of indicator, is colorless in the acidic solution and it becomes pink in the basic solution, and the pH range of this phenolphthalein indicator is 8.3 to 10. Mostly we are used methyl orange and phenolphthalein during the acid-base titration. These 2 indicators are the very important indicators which are used during the acid-base titration experiment. Actually, the titration is an experiment which is used to determine the strength of an unknown acid solution or base solution. Like if having a acid solution whose strength is unknown or base solution whose strength is unknown, the experiment is carried out, the titration experiment is carried out, and in this experiment the acid is neutralizes with the base. Like if the base is given, the NaOH solution is given whose strength is unknown, the experiment is carried out, the titration is carried out by the acidic solution having known strength. Like acid may be a strong acid or weak acid, like HCl or oxalic acid or acetic acid, and the HCl is added in the burette and the NaOH is taken in the titration flask. Titration flask contains the NaOH having the known volume but the strength is unknown. Slowly this HCl, this strong acid, is added in this titration flask. A point comes where the acid on base, the base completely neutralizes with this acid. This is called the equivalence point or the theoretical end point of the titration. And a suitable indicator is added in this solution so that we can easily determine the equivalence point of the titration or end point of the titration. The indicators, actually it is used during the titration experiment, which color change express the end point of or equivalence point of titration. The choice of indicator, which indicators are used during which titration, is depends on the pH curve, and the pH curve, it also depends on the acid and base, the nature of acid and base titrated, like many different types of indicator, and these indicators are used during the titration, and it depends on the nature of acid and base which are titrated. Like first type of titration is the strong acid strong base titration, and the pH curve of this titration, pH curve is the curve plotted pH against the volume of the base added or volume of the acid added, like pH and volume of base added or volume of acid added, maybe pH and volume of base added, pH and volume of base added. Like first is the strong acid and strong base titration. Like in the titration flask, suppose in the titration flask a strong acid is present, because the titration is going the strong acid and strong base titration. HCl is present in the titration flask. Slowly a strong base whose strength is known is added slowly. Initially the pH of this acid solution is very low because the solution is highly acidic, and as we added the base added, the pH changes, the change in pH is very slowly, and at the point, the equivalence point of the titration, the change in pH is very sharply, and at the middle point of this curve, it is called the equivalence point, and the vertical portion of the curve actually gives the choice of the suitable indicator. Like the equivalence point in the case of strong acid and strong base titration is actually pH 7. pH 7 equivalence point. That means we can use either methyl orange indicator or phenolphthalein indicator during this acid or base titration. The vertical position actually, it determines the choice of suitable indicator. In this case, if we use methyl orange as an indicator during the strong acid and strong base titration, the color change is shown during the pH 3.1 to 4.4. And if you use phenolphthalein as an indicator, the color change is shown at pH 8.3 to 10. The equivalence point is exactly 7. If you use methyl orange, the color change is shown in the pH range of 3.1 to 4.4. And if we use phenolphthalein as an indicator, the color change is shown in the range of 8.3 to 10. In case of the weak acid and strong base titration, that means in case of strong acid and strong base titration, we can either use the methyl orange indicator or the phenolphthalein indicator. In case of the weak acid and strong base titration, weak acid, like in the titration flask, the weak acid is present, and the solution is acidic in nature. And if we gradually added the base in the titration flask, the pH changes. The change in pH is very small because at the equilibrium point a buffer solution is formed which controls the pH of the solution, which controls exactly the pH of the solution. And as we base added, the pH changes, and the change in pH is very sharp in this range. And again the vertical portion of the curve gives the choice of the suitable indicator, and in this case the vertical portion is in the range of phenolphthalein, that is in the range of 8.3 to 10. That means for the weak acid and the strong base titration, phenolphthalein is the suitable indicator. Methyl orange is not a suitable indicator. It do not give the exact equivalence point of this titration. In the case of strong acid and weak base titration, strong acid and weak base, again the pH of solution is very less because the solution is highly acidic, and if we added a base, weak base in the solution, the pH again changes. And in case of strong acid and weak base, at the equilibrium point, again a buffer solution is formed which controls the pH of solution. The change in pH is very slightly, but in this range the change in pH is very sharply, and the vertical point is in the range of, vertical portion is in the range of methyl orange. That's why the methyl orange is the suitable indicator for the strong acid and weak base titration. Phenolphthalein, it do not gives exactly the equivalence point for this type of titration, strong acid and weak base titration. And the last is weak acid and weak base titration. In the case of weak acid and weak base titration, weak acid pH is slightly higher as compared to the strong acid, and as we added the weak base, the change in pH is very slightly changed. And in this case, the weak acid weak base titration, the change in pH is very sharply in this range, and vertical portion neither lies in methyl orange range or phenolphthalein range. That's why in case of weak acid and weak base titration, neither methyl orange or nor phenolphthalein can be used for the determination of the exact equivalence point for this titration. By knowing this, we can easily determine which indicators should be used during which type of titration, acid base titration. Thank you.